The next part in 6.2 is about skewness. Note that there are actually 3 ways to determine skewness of any distribution. You'll learn about stem and leaf diagram and box and whisker plot in 6.2, and later you'll learn about the Pearson's coefficient of skewness in 6.3. So let's start with the first one, which is stem and leaf diagram. To determine skewness, you need to look at the bell-shaped curve. And note that here, let's call it the center of the distribution. This is where most of the observation is. So if this is the center, you're gonna have the left tail and the right tail. So this is the left, this is the right, this is the left, this is the right. We usually determine the skewness based on the longer tail. So let's look at the first one right here. You can see that most of the data will be on the right hand side of the distribution. Therefore, the left tail will be longer compared to the right tail. So we will call this negatively skewed or skewed to the left. For the middle one right here, you can see that the left tail is of the same length as the right tail. Therefore, we can call this symmetrical. And for the last one right here, we can see that since most of the data is on the left side of the distribution, the right tail will be longer compared to the left tail. Therefore, the distribution is said to be positively skewed or skewed to the right. So how do we determine skewness from stem and leaf diagram? So you're gonna try and draw a bell-shaped curve next to the data in the leaf section here. So try and draw it as close to the data but not too close or too far, and make sure that it still has some curve. If you draw it too boxy, like the one I'm doing right here, that is wrong. So you need to make sure that it still has some curve to it. And as you can see, this is the group where you have the highest number of data. So this will be the center of the distribution. So what you're gonna do here is you're gonna tilt your head to the right 90 degrees. So you're gonna try and tilt your head to the right. So if this is the center, you can see that the left tail is longer compared to the right tail. And hence, this stem and leaf diagram is said to be negatively skewed. Now, what about this one right here? If you try and draw the bell-shaped curve, you can see that most of the data, the highest number of data will be right here. So this will be the center. And you can see that the left tail is the same length as the right tail. Therefore, this will be called symmetrical. And for the last one right here, if you try and draw the bell-shaped curve, you can see that this will be the center of the distribution. And the right tail will be longer compared to the left tail. So this is called positively skewed. Now, say for example, you have this data right here. So we need to draw the stem and leaf diagram. Note that all the data here has 2 digits. So now you need to determine which digit will become your stem and which digit will become your leaf. So the easiest one is that the leaf will only has 1 digit only, and it will be the last digit. So 7, 9, 4, 5, 7, 0, 6 here will be the leaf. Next, we need to determine the stem. The stem will be the rest of the other digit. Here you can see that the stem will be 1, 1, 1, 3, 3. But what about 7 and 9? Actually, it has a digit in front of it, which is 0. So 0 here will be the stem. So you're just gonna write the stem once only. So here we have the stem, which are 0, 1, and 3. Note that we have no 20s here. So even though there are no 20s here, in the stem and leaf diagram, you still need to include it. So in the stem, you're gonna have 0, 1, 2, and 3. That will be the stem. Next, we need to write the leaf. So note that when the stem is 0, the leaf that we have is 7 and 9. And when the stem is 1, you have 14, 15, and 17. So the leaf will be 4, 5, and 7. Note that when the stem is 2, there are no data with the stem 2. So you're gonna leave this row empty. And the last one is when the stem is 3. So you're gonna have 30 and 36. Therefore, the leaf will be 0 and 6. So that's how you draw the stem and leaf diagram. And as you can see, whenever you draw this stem and leaf diagram, you must make sure that your data is ordered like this. It must be in one column. This is important so that it will not disturb the skewness of the distribution. So you must make sure that they are in the same column. You also need to write the key in order to read the stem and leaf diagram. Let's say I want to try and read this data. So here you have 1 vertical bar 4. So what does this mean? We know that here this means 14. So if you know that this is 14, you know that the stem here will give you the tens. So this is 10, this is 20s, and this is 30s. So that's how you know how to write or to read the stem and leaf diagram. Next, for part B, we have this data. So the leaf will always be the last digit, which is 3, 4, and 1 right here. And the stem will be the rest of the leaf. So here we have 11, 11, and 12. So we're just gonna write 11 once and 12 also once. When the stem is 11, the leaf will be 3 and 4. And when the stem is 12, the leaf will be 1. So don't forget the key. Let's say I want to try and read this data. So here you have 11 vertical bar 3. And this one right here means the data which is 113. So now I know that this 11 here means 110. Therefore, this will give you 110 plus 3, which is 113. Let's do example 3 continued, where we are using the same example as the last one. So here we have already arranged our data from smallest to biggest. And for part E, we need to draw the stem and leaf diagram. So for leaf, we have this last digit here, and the stem will be the rest of it. So we can see that for stem, we're gonna have the digit 0, 1, 2, and 3. When the stem is 0, the leaf will be 5 and 9. When the stem is 1, the digit will be 0, 3, and 7. Just be careful, 7 here is repeated twice since we have 17 twice. When the stem is 2, the leaf are 1 and 8. And the last one is when the stem is 3. The leaf will be 3 and 5. Let's say I want to try and use this data as the key. So you're going to have two vertical bar 1, and this one right here means 21. For part F, I need to determine the number of peaks. So you need to draw the bell-shaped curve. So note that peak means where you have the most number of data, which is here. So we can see that I have one peak. So the number of peak is 1. But you need to tell me the position of the peak. And you know that here, the group will be tens, since this is the stem for 10, 13, 17, and 17. Now, what if your peak is here? Therefore, you can say that the number of peak is 1 at 20s. Now, let's look at this example. So, if you try and draw the curve, you can see that we have two peaks, which is here and here. So, the number of peaks will be 2. And you need to tell me the position of the peak. Based on the key, you can see that this data right here means 113. And therefore, this means that this group right here is 120s, and this one right here is 140s. Next, for part G, we need to determine the skewness. So if you look at our data right here, since this is the center of our distribution, we can see that the right tail is longer compared to the left. And thus this distribution is said to be positively skewed.